Here's a video on Solving Quadratics, Chapter 8. So when you're solving a quadratic, these are the steps that you need to go through. Make sure that the formula is equaling 0. Factorize the formula to express it as a multiplication. Use the null factor law and solve for x. The null factor law is this one here, that whenever two things multiply together to give an answer of 0, one of those two things must have a value of 0. It's the only way the answer would come out to be 0. So, this first one, I don't have to rearrange it to make it equal 0, it's already equal to 0. I don't have to factorize it or do anything to make it a multiplication. It's already a multiplication, it's x times 3x minus 2. So applying the null factor law means that either the first thing has to have a value of 0, or the second thing in the multiplication has to have a value of 0. The first thing was x, so x equals 0. The second thing is 3x minus 2 equals 0. To solve that second equation, I now do my BODMAS steps in reverse, and I do that in reverse order. So the instructions here are 3 times x minus 2. The last thing that happened was I subtract 2. So to undo that, I do the opposite thing and add 2 to both sides. And then once I get my next line, 3x equals 2, I then divide both sides by 3 to get x by itself. Those two values of x equals 0 and x equals 2/3, they're the two possible x values that could make a true statement out of that original quadratic. And I can put those values back in and check that they are correct. Second example here, we've got a quadratic with two linear factors multiplying together. Again, it's already equal to 0, already expressed as a multiplication, so I can go straight to my third step of using the null factor law. Either the first bracket equals 0 or the second bracket equals 0. I then use my reverse BODMAS steps to solve to find out what value of x makes that true. I subtract 1 from both sides to get rid of the addition of 1, and then I divide both sides by 2, and finally I get my answer of x equals -1/2. Over here I get my x term by itself by subtracting 3 from both sides. Then I get rid of that multiplying -4 by dividing by -4, and I get my final answer of x equals 3/4. In this next example, I've got a quadratic trinomial. It's not expressed as a multiplication. So the first thing I have to do is I have to factorize it to get x plus 5 times x minus 3. I can then solve each one of those parts to get my two answers. And example 4 is one where we don't even have it equal to 0. So first I must move that 30 across by adding 30 to both sides to get an expression equaling 0. I then spot that it's got a common factor, factorize it into a multiplication of linear factors, and then I solve each one of those things. Note that the 3 doesn't make any difference. That can't equal 0, 3 is always just going to equal 3, but the two brackets could, either of those could have a value of 0 to make the whole thing 0. If I go back to my original equation, I can put those values in, like x is equal to -2 was one of my solutions. 3 times -2 squared is 12, plus -2 times 21 is -42. -42 plus 12 does equal -30. It makes a true statement. So substituting them back in will always check your answer. Here's another example. This one's got surds in it, but remember, surds are just numbers. We move them around just like before, adding them to both sides or dividing, just to undo whatever the BODMAS step is. So the first bracket equals 0. So then I add root 3 to both sides and subtract the addition of 2. Or the second bracket equals 0, and then I subtract root 2 from both sides. This one has got a quadratic with only x in one term. So this gives me an alternative way that I could solve it. There's two ways I could do it. I can spot that that's a difference of two squares and then use that pattern to solve it into x equals -3 or x equals 3 on the left there. Or the other way I can do it is I can add 9 to both sides and then I can take the square root of both sides. Don't forget that when you take the square root there are two possibilities, the positive square root or the negative square root, which gives me the two answers again, root 3 or -3. And the last example up here is an example of a perfect square that we were using back in 7.5. So a perfect square there, we get x minus 3 all squared, and this one only has one answer because both of those brackets would give the same result of x equals 3. So when you're solving quadratics, there's a few different techniques you can use, and you can get one solution out of it, like these ones, this one over here, sorry, or you can get two solutions like all these other examples. You can also have quadratics where there is no solution.